on the two factors. One is the maximum torque available in the engine, the other is the friction between the wheels. So we'll try to solve the problem so that will give a better idea. So here we have a car which has a mass of 1500 kgs. So here I'm going to draw that. So I'm trying to keep this in an incline. So this is a car. So this is 1500. So let us have the CG of the car somewhere here. The CG is 0.6 meter behind the front wheel, and the total wheelbase which is mentioned in the problem is 1.6, and the height of this is actually 0.5, and the weight will be always acting downwards, that is W is equal to 1500 kgs, okay, multiplied by 9.81 meter per second square. That's the weight which is acting downwards. So there will be two components here. One is which is actually acting perpendicular to the road. One which is acting perpendicular to the road, that is called as W sin theta. Is it right? That's W cos theta. And one which is acting parallel to the ground, so that is actually W sin theta. Okay, you know that theta is this angle, that is the inclination of the gradient which the car is climbing. Now we will try to solve it. So in this vehicle, it is powered by an engine or maybe an electric motor, which has a peak torque of 200 Newton meter, and it has got a gearbox with a maximum reduction of 4. Do you think this reduction of 4 is from first gear, second, third, or fourth gear? Reduction of 4 is to 1. Is it fourth gear or first gear? It is first gear. In first gear, you will have, suppose the engine rotates 4 times, the output of the gearbox will rotate 1 time. Maybe you have seen that in the lab. Okay, so you have that. So you have this reduction at the gearbox, and one more reduction at the differential, which is equal to 3. So therefore, totally that the reduction of 4 into 3, which is 12. So that means the engine speed, if it is actually 1200 rpm, when it comes to the wheel, it will be just 100 rpm. Okay, so now with this data, we'll start solving the problem. And also some more details like the tire has a coefficient of friction of 0.7, now which is the data to be noted, and the wheel size is 0.3 meters. And one data I have missed, it is a front wheel drive. Assume front wheel drive. Assume front wheel drive. So which means that the driving wheel is the front, not the rear. So for this condition, we want to actually solve the problem. So this problem could be given for 8 to 10 marks. So the first part of the problem is quite easy, which could be for 3 marks if it is 8, and the second part of the problem could be for 5 marks. So let us solve the first part of the problem now. So the first part of the problem is determine the maximum magnetic incline limited by torque of the engine. So I will write this as limited by torque. Limited by torque. Okay. So here, there is a torque in the engine. What will be the torque at the wheels? The torque at the wheels will be equal to the torque engine multiplied by the reduction gear ratio in the gearbox multiplied by the gear ratio in the differential. So gear ratio in the differential. So now the torque in the engine was 200 Newton meter, and the gear ratio in the gearbox is 4. The gear ratio in the differential is 3. So 4 into 3 is 12. 12 into 2 is 2400. So it is 2400 Newton meter of torque. So this is the amount of torque available at the wheels. So this is TW, but we know that the relation between the tractive force and the torque. You know that torque is nothing but the radius into tractive force. If you want tractive force, that is the torque at the wheels divided by the radius of the wheel. So the torque at the wheel is 2400 Newton meter, and radius of the wheel is 0.3 meters. So this is so 3 8s are 24. So this becomes 8,000 newtons. Is it right? Please check.
Yes, sir.
It is 8,000 newtons. So the tractive force is Ft is equal to 8,000 newtons. So which means that at the wheel, at this point in the wheel, the forward force is 8,000 newtons. So if you don't get a feel of 8,000 newtons, you know that 1 kg is 10, approximately 9.81 or 10 newtons. So you can almost imagine this to be 800 kgs of force which is trying to pull this car forward. So that force is coming at the front wheels. Okay, now this is the forward force which is trying to pull the car forward. But what is the backward force? Backward force, is it W cos theta or is it W sin theta? So W sin theta is the backward force which is actually acting because of the gradient. It is trying to pull. The component of the gravity is acting like this. So let us equate this component which is going backward and the component which is going forward. So the forward force, is it captured? Is it in the view? Forward force is equal to backward force. Forward force is equal to backward force. Forward force is equal to 8,000 newtons. And the backward force is W sin theta. And W sin theta is nothing but, what is W, man? mg. mg sin theta. So m is 1500 kg and g is 9.81 meter per second square. And theta is not hard to find. So this is 8,000 on the left hand side. So here we have this kg meter per second square as newtons, because we know that since 1 newton is equal to 1 kg meter per second square, so the units are matching, so you can cancel this out. So you can see that the units are balanced across both the sides of the equations. So you can actually take this sin theta. So sin theta is equal to how much, man? Anybody can say? 8,000 newtons divided by this.
Theta is equal to 32.93.
So they have directly find this. So theta is equal to 32.9 degrees approximately. So here you can actually do this calculation by yourself, which means that this inclination is 32.9. And generally people speak in terms of a gradient. So gradient is actually mentioned in terms of the rise by run. So run is the forward distance and rise is the lift of the car with respect to the forward distance. So if it is 32.9, if you want this rise divided by run. So rise is nothing but the opposite side and run is nothing but the adjacent side. Opposite by adjacent is what? Now what trigonometric function? Tan theta. So tan theta, so that is tan 30 is equal to so much. What is actually tan 30? Find out what is tan 30. 0.577. So which is, which you can actually call it as 0.577. Okay, so here you can say if this is 0.577, you can actually write it as 1. Divide by 1, which means that for a run of 1 meters, the rise in this will be 0.557. Okay, or if you want to speak in terms of percentage, we said in the last class that if it is 45 degree, suppose if it is 45 degree, for a run of 1, you will have a rise of 1. For a forward distance of 1, if you have a rise of 1, then you know that it is 45 degree, then you call the gradient as 100%. So we can call this, suppose if this becomes 1, so then it can become 1 once it is 45 degree. Okay, now it is actually 0.577 divided by 1, so which means that the gradient is 57.7%. Okay, so we'll pause the video.